Hello students, and welcome to Math Weekly number 25. In this Math Weekly, we're going to focus on solving inequalities. Let's begin with a definition of inequalities, and then we'll look at our focus skills for today. An inequality is a statement that two amounts are not only equal, which means they can be greater than, less than, greater than or equal to, less than or equal to, or not equal to. Our goals for this lesson are to be able to write an inequality for a real-world situation, to check a solution to an inequality, to graph the solution to an inequality, and to solve an inequality. That's a lot of goals for today. Let's begin with writing an inequality for a real-world situation. When writing an inequality for a real-world situation, be sure to listen for keywords in the real-world situation's description. You're looking for words that signal adding, subtracting, multiplying, dividing, or one of the inequality symbols. Note, the same symbol can be explained more than one way. So for example, the greater than symbol might read greater than, or could read more than, or at least. All of these are ways of signaling the same symbol. So let's look at an example. At the dollar store, bags of Reese cups cost $3, so they're $3 each, and sodas cost $1.25. If Ben has $30, which means he could spend less than or equal to 30. If you only have $30, you can spend 30, or you can spend less than 30, but you can't spend more than. So if Ben has $30, which means he can spend less than or equal to 30, and wants to spend it on X bags of Reese cups and one soda, and is going to be our add symbol, write an inequality that represents the number of bags of Reese cups that he can buy. So he's going to pay $3 for each bag of Reese cups, which would be X, so 3 times X, 3 times however many he buys, plus he's buying one soda, which is $1.25. And that total, the amount of Reese cups, the amount for the Reese cups plus the soda, has to be less than or equal to 30. And there's your inequality. Let's look at another example. For her basketball team, Riley is selling candles. Each candle gives her team $6 profit. So you can see each candle is $6 profit. That's going to be multiplying. Number of candles times 6. If Riley must sell at least $90 in order to cover the cost of her uniform and sneakers, write an inequality to represent X, the numbers of candles Riley must sell. So her profit, which is $6 for each candle, so 6x, has to be at least $90. So it could be equal to 90, right? Or it could be more than 90. More than 90 would be fine. Her coach would be happy about that. So 6 times the number of candles that she sells has to be greater than or equal to 90. So let's talk about checking a solution to an inequality, our second skill. The solutions to an inequality is different than the solutions to most equations because many numbers can make the inequality true. So, for example, Riley's equation solution is X is greater than or equal to 15. This means that Riley could sell 15, or 16, or 17, or 18, and you could count for however high you want, candles. And all of these would satisfy the requirement of making $90 profit. To check a solution, check the minimum value, which in this case would be 15, and a value within the solution set, which would be one greater than or equal to 15, and also check the first number outside of the solution set to make sure it makes it false. So I should also check 14 to make sure that it does not make the inequality true. Let's look at an example. Is X is greater than 5 the solution to the inequality 2x plus 4 is greater than 13? Okay, so remember, we want to check the minimum value. So what is the smallest number that's greater than 5? So I'm going to check 6. I'm also going to check some number higher than 6. So what's a number higher than 6? I'm going to check 10. And this should make it true because it's part of this. And then last, I'm going to pick a non-example. So what is a number that is not greater than 5? And remember, we want to pick the one closest to the sample set, which would be 5. 5 is not greater than 5. And this should make it false, this should make it true, and this should make it true if it is a solution. So let's put 6 in here. 2 times 6 plus 4, is that greater than 13? 2 times 6 is 12, plus 4 more, is that greater than 13? 12 plus 4 is 16. 16 is greater than 13, so yes, that's a solution. Let's try 10, because 10 is greater than 5. So 2 times 10 plus 4 more is less than 13. 2 times 10 is 20, plus 4 is greater than 13. So that's 24 is greater than 13. That's also true. So far, this seems to be holding true. 6 makes it true, and so does the numbers greater than it. Now, 5 should make it false because 5 is not greater than 5. Let's check. 2 times 5 plus 4 more is greater than 13. 2 times 5 is 10. 10 plus 4 is greater than 13. So 10 plus 4 is 14, and 14 is greater than 13. So this makes it true when it should have made it false, which means that x is greater than 5 is not the solution. It's part of the solution, but not all of it. Let's try another one. This is example number 2. Is x is less than or equal to negative 2 the solution to the inequality 2x plus 8 is less than or equal to 4? So remember, we want to try the smallest value. So we have x is less than or equal to negative 2. So I'm going to try x is negative 2. It should make it true because it says that it can be equal to that. Now I need to pick something less than negative 2. Let's try negative 5. And that should make it true because negative 5 is less than or equal to negative 2. And the last thing I'm going to try is a non-example, which should make it false. So I'm going to try 0. That'd be easy. So the smallest is negative 2. Let's see if that makes it true. 2 times negative 2 plus 8 is less than or equal to 4. So that's negative 4 plus 8 is less than or equal to 4. Negative 4 plus 8 is 4. 4 is less than or equal to 4. So yep. Sorry, that plot. Which is yes, that makes it true. So far this looks like it's a solution. Okay, let's try negative 5 in there. 2 times negative 5 plus 8 is less than or equal to 4. 2 times negative 5 is negative 10 plus 8 is less than or equal to 4. Negative 10 plus 8 is negative 2. Negative 2 is less than or equal to 4. That's true. So far it's looking like the solution. Now let's try 0. 2 times 0 plus 8 is less than or equal to 4. 2 times 0 is 0, plus 8 is less than or equal to 4. 8 is less than or equal to 4. No, that makes it false, which is what we were hoping for because this was the non-example. So yes, this seems like it's the solution. So yes, x is less than or equal to negative 2 is the solution. Alright, let's look at our third skill. Graphing a solution to an inequality. We graph the solution to an inequality on a number line. Step number 1, after you've drawn your number line. Draw a closed or open dot on the boundary number. Closed if it can be equal or open if it cannot be equal. Step number 2, shade the direction of the inequality symbol. If it's greater than, you shade to the right. If it's less than, you shade to the left. So let's look at an example. Graph the solution, x is less than 3. So I'm going to draw my number line. You don't have to label a lot of numbers. And it doesn't even have to have 0 in the middle if you want to. 1, 2, 3, 4, 5, 6. This is fine. I like whatever the boundary number is to be near the middle. That's just my personal preference. So our options are a closed dot on the boundary line if it can be equal, or an open dot if it cannot be equal. Does this have an equal sign? No, this is just less than, not less than or equal to. So it cannot be equal to, so we need an open circle on 3. That's step 1. And then we need to shade the ones that are less than 3. Well, less than goes to the left, so I just shade over my line like this, making it dark. It's a little hard to do on here. It's okay. And you shade the arrow to signal that it could keep going. So this is our solution set. Any number down here in this darkened arrow will make this solution true. Okay, let's look at another example. Graph the solution, x is greater than or equal to -2. So I'll draw my number line. I'll have like -5, -4, -3, -2, -1, 0. Now, remember, it's a closed dot if it can be equal to, an open dot if it cannot be equal to. This has an equal than sign under it, so I'm going to make a closed dot on -2. And it says greater than -2, and greater than goes to the right, so these are all the numbers. Greater than 2, so I shade in this direction and also darken the arrow. Last, solving an inequality. To solve an inequality, use inverse operations to isolate the variable. Remember, whenever you multiply or divide each side by a negative value, it will reverse the inequality symbol. So let's look at 2 examples, one where this happens and one where it doesn't. So example number 1, solve 3x plus 9 is less than -6. So the first step, remember, whatever you do one side, you got to do the other. I'm going to take away 9, so that 9 minus 9 makes 0, and I have 3x left. If I take away 9 from this side, I need to take away 9 from this side. So I have 3x is less than -15. What's the opposite of timesing by 3? Dividing by 3. And we do that because 3 divided by 3 makes 1. But if I divide this side by 3, I need to divide this side by 3. So x is less than -5. This is the condition. Any number less than -5 will make this true. And we could go back and check that as well. Now let's look at the same terms, except the only difference is the negative sign in front of the 3. So to solve -3x plus 9 is less than -6, I'll again subtract 9 from each side. So -3x is less than -15. But now when I divide by a negative, which happens to be -3, -3 divided -3 makes 1, so I have 1x, or just x. But since I divided by a negative, I need to flip this sign to become greater than. And -15 divided by -3 is 5. So x is greater than 5. So let's summarize what we've learned about inequalities. Inequality is a statement that is not only equal. An inequality can be greater than, less than, greater than or equal to, less than or equal to, or not equal to.